We're good? All right. So welcome, everyone. My name is Kenneth Hjelmer. I'm a consulting architect at a company called Aria in Denmark. In this session, we're going to talk about what Cloud-Init is, how it works, and how we can use it in VMware. We're also going to look at the areas where VMware has integrated Cloud-Init today, which is in vCenter, using the guest customization API, the customization specification, and the cloud templates in Aria Automation. So what is Cloud-Init? It's basically a declarative configuration tool for configuring Linux operating systems that reads and processes a provided YAML file at boot. This allows us to automatically set up users, packages, updates, configure services, and much more without manual configuration. It was born out of a need to make the deployment of cloud instances faster and more automated, and originated at Canonical, the company behind Ubuntu, around 2009 when cloud computing was about to take off. Back then, setting up cloud instances was quite a manual and time-consuming task. So Cloud-Init was developed to simplify this process, allowing instances to automatically be configured at first boot. It was initially designed to work on Ubuntu within Amazon EC2, but Cloud-Init quickly became popular for its flexibility and simplicity. Over time, it's evolved to support a large range of Linux distributions, not only Ubuntu, and became the industry standard for instance initialization. When it comes to VMware, Cloud-Init is implemented to help automate the configuration of virtual machines, just like it is in any other cloud environment. VMware supports Cloud-Init from vSphere 7 Update 3 and in vSphere 8 using through the customization specification in the UI. So imagine you deploy a new virtual machine in your private cloud. Cloud-Init will then take care of all those important first steps for you, installing all your updates, your software, configuring your applications, download, execute scripts, and so on. By including single YAML file in your instance metadata, we can ensure that every server boots up the same way every time. And do this the same way over and over again. In order to prepare our target VM or our template to be customized with Cloud-Init, we need to configure a few things. First of all, we need to install Cloud-Init. In Ubuntu, you don't need to install this, as this has been included since version 9.10, released in 2009. We need to define a data source for Cloud-Init to figure out where to read the configuration metadata. We need a metadata YAML file that contains our initial network configuration. We need a user data YAML file that contains our configuration definition that instructs Cloud-Init on which task to execute. And that is it. The metadata YAML file provides general information about the virtual machine instance itself. So it's the instance name, the host name, and the initial network configuration when the virtual machine boots. It contains non-specific user information that is crucial for identifying the virtual machine and configuring some of its fundamental properties, and it's a mandatory file. This is an example of a user data YAML file, also known as a cloud config file. The purpose of this specific configuration file is to set a static IP address, install Python and Git, set a host name, and to create a local file in the /etc/cloud directory when it's done. The first section enables us to update the repositories and already installed packages. This ensures that the operating system and applications are always up to date. The packages section installs packages. In this case, it installs Python and Git. Doing it this way uses the built-in package manager to install the application. The write file section enables us to create files and content during Cloud-Init run. In this example, we create a new IP configuration file for NetPlan containing our static IP configuration that we want to apply to the server. This will create a local file called 99 installer config YAML file in the etc/netplan directory. The run CMD section is specifically useful as it allows us to execute commands just like you were logged into the operating system yourself. We set a host name, and lastly, we create a final message indicating that the deployment is complete. So how do we get this user data and metadata into the virtual machine? We can choose to create an ISO file using the geniso image function in Linux, attach it to a virtual machine that will then be read by the virtual machine when it boots. But creating an ISO image for each virtual machine is a manual and quite time-consuming task. So instead, we can populate the data through VMware tools using the guest info interface that is available to the operating system when it boots. Cloud-Init will then read the guest info properties in VMware tools that contains our metadata and configure the virtual machine accordingly. Looking inside the virtual machine, we can see that the configuration data is available in a library called cloud and verify that our service has been configured correctly. Upon further inspection, we can see that the 99 installer config YAML file exists and has been applied, providing us with a static IP address. And finally, we can see that the deployment.completed file has also been created. So what are the options to configure a virtual machine with this in vCenter? Since the release of v3.8, we've had the option to provide metadata and user data when customizing a Linux virtual machine using our customization specification. So we start by creating a new customization specification, providing a name and a target OS. Selecting Linux gives us the option to provide the cloud config data. So first we provide the network metadata, the initial metadata that we saw before. And then we provide the user data. This specific user data in this customization specification installs Nginx and Git, clones a Git repository containing a web-based version of Pacman, and runs the website, configures the website. So we finalize the customization specification and press OK. So the customization process is laid out like this. We deploy a virtual machine from a template that has Cloud-Init installed and configured. A Cloud-Init enabled customization specification is applied during the deployment. The metadata YAML file is stored in the guestinfo.metadata property of VMware tools. So is the user data stored in the guestinfo.userdata property of VMware tools. So the virtual machine is booted. The Cloud-Init services reads the metadata file and configures the virtual machine accordingly. It then reads the user data section that we also uploaded, stores it in /var libcloud, and configures the server based on that configuration. If we look at the user data file, we can see that it's instructed to install Nginx, to install Git, to clone a Git repository, and configure the web server. Then the deployment is complete. Opening our browser will also reveal that we can now actually play a game of Pac-Man. But what if I want to use PowerShell instead? Luckily, we can use the vCenter customization API to achieve the same goal. William Lamb has been so kind to have published an example of how to customize a virtual machine using Cloud-Init, providing metadata and user data through REST API. So we start out by deploying our virtual machine from our Cloud-Init configure template and leave it powered off. The metadata is provided through a metadata JSON file containing the same DHCP configuration as before. We need to provide some variables to the script, such as vCenter credential, DNS information, and the virtual machine that we are customizing. User data is provided as variables to the script, just as we did before. And the script is invoked. What we'll see is that on the virtual machine, we will get an event showing that the virtual machine has been reconfigured and is pending customization. The configuration process is much like the process when using customization specification, with the only change that the PowerShell script outputs a JSON object containing our configuration, user data, and metadata instead. So we provide this JSON body to the API endpoint. Metadata and user data are still stored in the guest info property of VMware tools. And Cloud-Init will read the properties, copy the data into the virtual machine, and configure the virtual machine accordingly. If you're using Aria Automation, a cloud config section is already built into the cloud template. By using conditional statements, we can adapt the cloud config file based on the user input and create a fully customized instance of the selected operating system. For instance, creating disks and mounting storage, configure static IP addresses, or creating local users with expired passwords that need to be recreated when they log in the first time. The resulting user data contains the disk layout and configuration, as well as other commands to configure the server. We can see in the log files that the disk's volume and volume groups has been successfully configured based on the inputs of the requester, and that the disks are available, mounted, and ready for use. But what if you don't have Aria Automation? Chances are you have Aria Automation Orchestrator. Orchestrator is included in most vSphere licenses today. To automate the customization process, we need to build a workflow that creates our metadata, that creates our user data, that clones our Cloud-Init-enabled template, customizes the virtual machine using the vSphere customization API, and power on the virtual machine. So in Orchestrator, we still create the metadata content. This also provides the host name as a variable. In the user data, we provide the IP information, the IP address and the CIDR as a variable, along with the server type to create the user data output to be sent to the virtual machine. The deployment spec is used to instruct vCenter to clone our virtual machine. Most of this data is static, but it could be provided as inputs. Once the virtual machine has been deployed, we create a REST API body, as we also saw in our PowerShell example before, and sends this request to the vSphere customization API before booting the virtual machine. But instead of running workflows from within Orchestrator, which is not the greatest UI, we can integrate it into vCenter instead and initiate our workflow from here. So I've set up the resource pool to publish available workflows when you right-click the resource pool. So we select the automation orchestrator and run workflow. This populates our available workflows, Cloud-Init demo, which populates our input fields. So in this case, I will choose a server type. This server type installs Nginx, configures a static website, and configures it. So we provide a host name, we provide an IP address, and we provide a CIDR. So when we submit this form, we can see in the Orchestrator log file, still inside vCenter, that our user data file has been created based off our inputs. And we can see our template also being cloned in vCenter. If we peek into the boot, section of the server, we can see that Cloud-Init is still in process of installing available packages and update, as well as configuring the Nginx server we asked it to. Once this is done, we will get a message in the bottom stating that the deployment is complete. We'll just give it a second. Come on. There it is, web server deployment complete. And if we go to our website, type in our IP address, we can also see that the Nginx web server is up and running. So what we just achieved is to create the cloud config user data and metadata file, clone a template, inject it into the virtual machine using the customization API, started the VM in 1 minute and 13 seconds. The boot sequence and Cloud-Init configuration took about 58 seconds more, totaling about 3 minutes from a template to a customized virtual machine. Cloud-Init also has a vast selection of built-in modules that can be used inside your cloud config file. As of today, there are 66 different modules that we can use. We'll have a look at the most used ones. The Ansible module allows the integration of Ansible playbooks during Cloud-Init configuration. You can provide your Ansible playbooks as part of your cloud config file, and Cloud-Init will execute them, allowing for automated configuration management right after the instance boot. Similar to Ansible, the Chef module integrates the Chef configuration management tool. It can configure instance as a Chef client or a standalone setup, enabling recipes and cookbooks to be executed at boot. And lastly, the Salt Stack integration, allowing salt menus to be set up and configured. This module ensures that states are applied and to provision and manage instances automatically. So to sum up some of the use cases of Cloud-Init, unattended and automated configuration of virtual machines at boot. We can use Cloud-Init to define the initial configuration. This ensures that newly launched instances are always ready for production and compliant. Dynamic setup of networks and disks enable us to automate rollout and apply instance-specific network and disk configuration to our new virtual machine. We can inject SSH keys at boot for passwordless authentication, further enhancing security. We can automate software installation and configuration changes and use pre-developed scripts at time of boot. Enforcing security hardening baseline by configuring firewalls, applying security patches, and implementing security policies. This ensures that instances that are launched with a baseline level of security. We can integrate with Aria Automation Orchestrator, Automation, or Ansible, or other configuration management tools to further increase the level of automation. And we can integrate with automation to create a dynamic configuration with Aria Cloud templates. And of course, enforce default configuration and updates on all deployed servers. Any questions? Yeah. No, but it could be. I will. Otherwise, thank you. If anyone is included in the rewards program, feel free to scan your QR code. And otherwise, have any questions, find me, connect with me on LinkedIn. I'll be happy to answer any questions you have. Thank you for coming.